So we'll take examples, students. You will understand. I'll just repeat. I'll take a glimpse of it once again. Left to right for the coordination compounds, left to right to left for the complex ion, right? And if it is a ligand, IDE, O, ITE and ATE by E of that will be replaced by O. And if it is a polydentate ligand containing already di, tri, etc., you have to put bis, tris, tetrac, etc., etc. Anionic complex, metal ion has to be ended by the word ATE. Whether it is anion, cation or the neutral complex doesn't matter. Always keep the oxidation number of the metal ion in bracket. After the naming the metal ion, you put the oxidation state in bracket. Now let us take few of the examples, and so you will be very clear regarding the IUPAC nomenclature. Easy. We'll take one by one, students. We'll take one by one. So first we will take, for example, cobalt, pentamino cobalt complex. We will take it with Br. Yes, so for this complex, how do you name? Just take a look whether it is a positively charged or the negatively charged complex. Just take a look. So it's a positively charged complex or the cationic complex it is, because counter ion is a negative ion, right? It's a cationic complex because counter ion is sulfate ion, negative ion. This has to have a positive charge. Whatever it may be, first we have a rule left to right, right? So you need to name the complex ion first, then you have to name the counter ion. Complex ion need to be named first, then you have to name the counter ion. In the complex ion, what needs to be named first is right to left. That is second rule for you is right to left. That is, in the complex ion, you need to name ligand first, then you have to go for the metal ion. So ligand, you have two kinds of the ligand, two ligands are there. It's as easy as that. You have to put it in the alphabetical order. For alphabetical order, you have to arrange it. Two ligands, you have amino ligand is there and bromine ligand is there. Br, bromine B, amino A, right? So the number doesn't matter whether it is penta, tetra or all those things. This is penta, don't consider P, it is amino ligand, so A. So A comes first or B comes first? A comes first, right? So you have to name if you are having two or more ligands are there, then it has to be arranged in the alphabetical order. That everyone knows, right? So that is how do you name this? That is, I will start with pentamino, right, or pentamino, right, pentamine, right, bromo, pentamine or pentamino, bromo, right, bromo. Now this is a positively charged complex. Keep the central metal ion as such. What is this? What is the central metal ion? We have cobalt, right? Cobalt is the central metal ion. Pentamino, bromo, cobalt. What is the oxidation state? Oxidation state is Br minus already there, right? Which has neutralized this. That means the complex ion is having the plus 2 charge, SO4 minus 2 is there. To have a plus 2 here, this has to have plus 3. Otherwise, Br minus is already neutralizing minus 1 charge here. That means cobalt, the oxidation state is plus 3. That means you put it in the bracket after the cobalt, put it as 3. Finally, you have to, this we have named pentamino, bromo, cobalt 3. Finally, we have a counter ion. What is the counter ion here? Sulfate. So, this is the name of the coordination complex. This is the name of the coordination complex you have. Right, pentamino, bromo, cobalt 3 sulfate is the name of this complex. Clear? So we'll go for the next example. Next example we will take it, students. The next example is PT, platinum, tetramino, right, Cl2 we have and Br2. So this is the complex we'll go. How do we name this? See again, just check either it is a positive charge or negative. This is a positively charged complex because counter ion is a negatively charged. So this is a positively charged means you have to keep platinum as platinum. In front of the platinum you have to keep the oxidation number. Right? Start from the complex ion first, left to right. In the complex ion, name the ligand first, that is ligand, 4 amino groups are there. In the ligand, amine will be named first. So that is tetraamino, right? Tetraamino, amino. Chloride will be named as chloro, right? Tetraamino, chloro, right? Correct? Chloro. Because chloride, IDE, has to be replaced by O, chloro, right? Platinum, you keep it as platinum because, why? Because it is a positively charged complex. Platinum. Check the oxidation state. This is +2 charge. That is the reason we have 2 Br minus ion. To have +2 here, platinum should have +4 charge, because already 2 of the the Cl minus ions are there inside, which has neutralized +2 charge of this. That means the charge of the complex +2 means the platinum should have a oxidation state 4. That is tetraamino, chloro, platinum 4, bromide, platinum 4, bromide. This is IDE has to be replaced by O. It is only for the ligand, not for the counter ion. Counter ion, you keep it as such. Bromide, how many bromides are there? 2 bromides are there. Doesn't matter, you don't have to mention a dibromide, no. Counter ion, you keep it as such. Whatever may be the number, you just write it as bromide. That depends on how many has to be there, that depends on the oxidation state. That will be decided anyhow. Because based on the oxidation state and the, the central metal ion, all those things will speak about how many counter ion will be there. You don't have to worry. Keep it as such. Tetraamino, chloro, platinum 4, bromide. This is the name of the PT ammonia 4 times Cl2Br2. So the next complex we will take it is NiCO 4 times, neutral complex. We don't have any problem, we will be naming by one word. Right, that is, so in this what has to be named first? Ligand has to be named first. What is the ligand? Carbonyl ligand. That is tetracarbonyl it is. How many carbonyls are there? Tetracarbonyl. How many carbonyl? 4 carbonyls are there. Tetracarbonyl, keep it as such, nickel, right? Oxidation state is 0, so put it as 0, nickel, tetracarbonyl, nickel, 0, that's it, nothing else is there. Tetracarbonyl, nickel, 0 is the name of this complex, very clear. So this is how we will be naming. We will take few more examples, students, quickly we will take it. So that is CO, ammonia 4 times SO4, that is this complex. Again a cationic complex, start from left to right, cationic complex, +2 charge, and the oxidation state of the copper is 2 because it is a neutral ligand. So ligand you name first, that is tetraamino, copper 2 sulfate, tetraamino copper 2 sulfate. This is the name of this complex, tetraamino copper 2 sulfate, right? Very simple. We will take few more examples. K4 FeCN6, K4 FeCN6. If someone asks to name this, how do you name this? K4 Fe. So this is an anionic complex because the counter ion is a positively charged species. You start from this side to this side, you go ahead. That is, first one what we will be naming, that is counter ion. Counter ion is potassium, right? Potassium. Next the complex ion comes into the picture. Potassium. Complex ion you have, ligand has to be named first. What is this ligand? Cyanide ligand. Cyanide, that is cyanide, right? IDE has to be replaced by O, that is cyano, right? Potassium, how many cyanides are there? 6. Potassium, hexacyano, don't write it as iron because it is an anionic complex. Always you have to write the metal ion with the suffix ate, that is, it is hexacyano, potassium hexacyano, ferrate, student, ferrate. If it is nickel, nickelate, cobaltate, iron, ferrate, so it is hexacyanoferrate. What is the oxidation state? Put it in bracket, always the oxidation state, potassium hexacyanoferrate oxidation state is 2. That is, you write it in the bracket, potassium hexacyanoferrate 2. Clear? Similar way, you can take K3, FeCN6. That is only 3 potassium ions are there. That means charge on the complex is -3. Ion should have a +3 oxidation state. How do you name this? Potassium, right? Hexacyano. Now the hexacyanoferrate. Now the oxidation state is not 3, it is not 2, it is 3. Potassium hexacyanoferrate 3.